Hello WFCO girls. I want to record a quick video to tell you what we did in class on Thursday while you were gone. First thing I did is I just pointed out the links to those guides that I handed out Wednesday in class, the sample lab report about the mandrakes that will help you see what a lab report looks like, and the short guide that just explains each element of a lab report and what goes into it, maybe a little specificity for this particular lab. The last thing is the link right here. That this is new. I did not show you guys this before. This is the combined class data that you will need to use for your lab. A little bit different than what I put on one of those sheets. Minimum I need you to have 2 graphs. If you want to include all 4, you can. But the minimum 2 that you should have for sure on there are the 2 class graphs. If you want to put your own graphs on there, you can with your own data. The reason you don't have to is because your data is already included in the overall group data. I'm going to show you really quickly how to graph that, just a few little tips and tricks. So this is the water temperature trials. You can select all of that data. And there's quite a bit of it. So all that data, and then can't see this quite yet. Let me move this. Okay. You should be able to now hit the graph or insert chart button. Either one will work. And it should go ahead and make a nice little graph there for you. Things that this is missing right now, it's missing a title, the effective IV and DV. It's missing the independent variable label with units on the x-axis. For this experiment, that is the temperature in degrees Celsius. And then it's missing the y-axis, the dependent variable label with units. Reason you wouldn't want, and let me show you something actually there. So I click on that, I go to chart and axis titles, vertical axis title, and I want to call this time. Really, really, really important to put units in there, parentheses S for seconds. If you said, I'm going to actually put reaction time in there, reaction time. If you only put down reaction time, I wouldn't know if you're talking about 100 weeks, minutes, fortnights, years, hours, whatever else. It's going to use units. So units should go there as well. And the last thing, to put a trend line in there, remember you click on a dot and then you can hit add trend line. You can mess around with what type of trend line that possibly would be. Give me 1 second, thank you. So that is how we record sorry, I was interrupted there. That's how we deal with a graph. You should have that graph. You can copy and paste it and actually put it into a random Google Doc. Let's see if I've got a random one to put it into. We can just do a brand. No, do not need folder. You can actually just copy and paste it in here now. This is a new feature. So I'm trying to hit paste. Let's see if it wants to work. Oh, that's a B. That's from earlier, another project. Let's go back here. Control C. And it actually lets you click that whole spreadsheet in here. This one's actually linked, so if I change something in that original spreadsheet, it will update it on this page. So you should have both of these 2 graphs in here. And note that I want you to make a copy of this file before you start editing it. That's because this is for the whole grade. You don't want to make a graph that the whole grade's going to see. So you should do the same thing for particle size, and this graph will look a little funky. You definitely want to add a trend line onto that to see what's happening. Okay, second thing that you guys missed. That was the first thing. Second thing you missed was a little bit of a talk about the discussion section. First part, let's get rid of this. Okay, I don't know why the horizontal axis title is not going away. That's just going to be there. So, first part of the discussion section is revisiting your hypothesis. You want to evaluate if what you said, okay, so I hypothesized that if you harvested them earlier, it would still be effective at curing petrification. And I kind of saw that. It wasn't effective at very early ages. It was effective at later ages. But still before adulthood of the mandrake. So what I said is that the data is partially supporting my hypothesis. One thing that's super, super important is you should never use the words right, wrong, correct, incorrect, any of that. The reason for that is, here's an example. Let's say that L's on the WFCO trip. Let's say that L has a theory that the number of pancakes that she eats before a math test will affect her math test grade. Before her first math test, she eats 10 pancakes and she gets an A, and then before her second math test, she eats 2 pancakes and she gets a C. The data actually supports her hypothesis that the more pancakes she eats, the better she does on her math test. That doesn't mean she's actually right or correct. It just means that the data she collected does support what she said. So we're never right or wrong. You probably heard the idea that the theory of that gravity is still considered a theory. It's not a fact. That's what we mean by that. Is every single test that we've ever done in the history of mankind has supported gravity, but gravity is not a fact. And we might talk a little bit more about that idea later this year, but I always talk about it supports or doesn't support or partially supports your data. Okay. Part 2 is all about experimental error, sources of error, and particularly control variables. So think about things that affected your results. So in this lab, I talk about, we should have used same ages of cats because young cats were easier to cure than older cats. That was a source of error. In your lab, this would be something like the powder took a long time to add, and so it actually reacted over a longer time than it normally would have. I want to be clear on one thing that is not considered a source of error. If you did something like, if you broke an Erlenmeyer flask, I consider that a mistake, but that didn't actually influence your results. It didn't make your reaction go longer or shorter than it was otherwise supposed to. Or let's say that, who's somebody else who went on your WFCO trip? I think Elena, or maybe you were just absent. Let's say that Elena forgot to record a trial. That's a mistake, but if you forgot to record the trial, you had to do it over again, and that didn't influence your results. So if you make a mistake like that, that's a mistake, but it's not something that we would consider a source of error. A source of error is anything that affected the results you collected. So think about what could have potentially affected your reaction time. Last is new experiments for next time. So now that we've done this experiment, what do we want to try next? I'm saying in here, maybe we want to test that mandrake root on people instead of cats. Or maybe we want to test and see if we can use preserved mandrake roots instead of fresh mandrake roots. For your lab, maybe instead of doing the lab with water and Alka-Seltzer, you want to try it now with ethanol or acid or milk or some other liquid. Or maybe you want to try and see how temperature affects the decomposition of a banana. You can try storing a banana at a bunch of different temperatures and see how quickly it goes brown or something like that. So the idea is, the middle paragraph is what would you do better next time for this same lab to get better results. The third paragraph is what would you do next time as a fundamentally new experiment that's testing something different. Okay, hope you guys all had a good time at the luncheon, and this lab report is going to be due Tuesday actually. I made that announcement in class as well. Have a great weekend.